Do you know what is RMS or root mean square and how it is different than a standard deviation? If you have seen some of the data sheets that the manufacturers gives for your multi-beam system or your GPS system or any other surveying equipment, you must have seen that they write the accuracy and within bracket a RMS value. Okay, so what is this RMS? So RMS full form is root mean square. It's a measure of the magnitude of varying quantity. So RMS gives you a value, that's an average value around the known point against which it has been measured. So suppose you have a known position and you do a 50 sets of observation, and then you can find a RMS value of the root mean square value for that equipment based on the known position or the known value. Now for standard deviation it is completely different. Standard deviation can be from a known point or value or from any unknown point or any unknown value. Suppose you are going out for a ground control point observation and you put your GNSS system and you observe for 100 sets of data, and then the standard deviation will give you a distribution of your error around the mean of that value. So there is a fundamental difference between a RMS and a standard deviation. When you want to buy a equipment, you mainly look for the RMS value. But when you are going for a survey, that time you have to give the client to say that this is my standard deviation, which gives you a confidence that how good is your data. Let me show you on an Excel sheet how to do that. So here I have 50 sets of data, easting and northing. And the first thing that I want to do is to find the difference from the mean. So I take the mean value, I take the average value of it, and then I find the difference from the mean. Okay, it is as simple as that. Difference from the mean is this value for the easting and this value for the easting for this particular value. So the average value minus that particular value, and I find the difference from the mean for the easting and difference for the mean from the northing. Okay, so once I find that, then I can do the square of this. Okay, I can find out the square of the difference from the mean. I do a square of D80, that is this number, and square of this difference of the mean for the northing. So once I find that, then I can find the variance. Okay, in this formula I take the average of the squared value that I have created in this. So this is the average and that is the variance for the easting and for the northing. And then I find the standard deviation by doing the square root of that variance number. So that gives me the standard deviation. Okay, now for the RMS value, you need an actual value of that point around which you are measuring. So this is my actual value and I have got certain values here. So you find the difference in easting and difference in northing, and then you find the square root of the difference in easting and square root of difference in northing. Then you add these two numbers together. Once you have added that, and you then create an average of that. Okay, you have to add the square of difference of northing and square of difference of easting and add them together, and then you average all this value together, and then you get the HRMS or the horizontal root mean square. So you simply do a square root of that average. So that is the horizontal root mean square. Now sometimes you may have seen that there is something called 2D RMS, that is two-dimensional RMS or three-dimensional RMS. Therefore easting, northing and height or latitude, longitude and height. So 2D RMS is double of that value. You just double it. 2 into square root of N102 or this average number. That is the 2 times of this average number is your 2D RMS. 3D RMS is the 3 times of this value. So if this 2D RMS or HRMS values are very small, then it's normally a good data. If it is higher, then it's not supposed to be good. So you have to look for very precise, very small amount of HRMS value. So 1D RMS is for single value like distance measurement, 2D RMS is for horizontal positions like easting and northing, and 3D RMS is for 3D position like lat, long and height. Okay, so I hope this small video has given you some idea about the RMS system and the standard deviation system that a lot of people talk about, and I bet most of them do not even know what they are talking about. So if you like this video, please give it a like and thumbs up and comment below if you want to know something else. Thanks for being here. I'll see you in the next video.